These are reasons for proof starting with Unit 4. The first reason that we have is the alternate interior angles theorem. And what this tells us is that if we have parallel lines and a transversal intersects both of them, then the alternate interior angles are going to be equal to each other. For example, if we have these two lines and we know that they're parallel to each other, then we can conclude using this reason that the measure of angle 1 is equal to the measure of angle 2. The next one, consecutive interior angles. So once again, if we have parallel lines and then we have the transversal connecting them, what we can say with this one is that these consecutive interior angles, or these same side interior angles 3 and 4, are supplementary to each other. Next we have the alternate exterior angles theorem. So once again, these lines must be parallel to each other, and if they are, then we can conclude that those exterior angles 5 and 6 would be equal to each other. This last one, I'm calling it a theorem, could also be a postulate because it's really the basis for all those other ones. But the same scenario holds that if we have these two lines parallel to each other, then these corresponding angles 7 and 8 would be equal to each other. So these first four reasons that we have are all properties if the two lines are already parallel to each other. The next four reasons that we have are all converses, so they work in the opposite direction. So here's what this is going to look like. If we have two lines, a transversal, and if angle 1 is equal to angle 2, so if those two alternate interior angles are equal to each other, then what we could say is that line L is parallel to line K. In other words, we're proving that these two lines are parallel to each other. We're going in the opposite direction. Next, we have two lines, a transversal. Here's angles 3 and 4. If we know that angles 3 and 4 are supplementary to each other, so if we're able to prove that, so angle 3 and angle 4 are supplements, then what we could conclude is again that L is parallel to K. Next, alternate exterior angles converse. So if we can get angle 5 equal to angle 6, then what we can conclude once again is that L is parallel to K. And for our last converse, we have the two lines. If we can get corresponding angles 7 and 8 equal to each other, then what we can conclude is that line L is parallel to K. So these are all ways to prove that two lines are parallel to each other. You don't start with the lines being parallel. You have some angles equal or supplementary, and then you're able to conclude that the two lines are parallel to each other using these converses. Now we're on to reasons for proof for Unit 5. The first one is the triangle angle sum theorem. So we have a triangle. The three angles inside of the triangle, angles 1, 2, and 3, would add up to 180 degrees. Next one, we have two triangles, and if we have these two triangles congruent to each other, let's go ahead and give them names, triangle ABC and triangle DEF. So if we know that triangle ABC is congruent to triangle DEF, then what we could conclude is that the corresponding parts of these congruent triangles are congruent. In other words, I can be specific and say then because of this statement that segment AB is congruent to segment DE. We could also say that segment BC is congruent to EF, segment AC is congruent to segment DF, angle A congruent to angle D, angle B congruent to angle E, and angle C congruent to angle F. We can say any one of those corresponding sides or corresponding angles are congruent once we know those triangles are congruent to each other. Now we're on to the four ways to prove triangles congruent. The first one we have is SSS. So if we have these two triangles and all the corresponding sides are congruent, then our conclusion is that we have congruent triangles using side, side, side. Our next way to prove triangles congruent is SAS, or side angle side. So if you have these two sides congruent to those two sides, and also the included angles are congruent, then our conclusion again is that we have congruent triangles. We need the name of those triangles, but we know those triangles are congruent to each other. Our next reason is angle side angle. So we have two angles congruent to each other. And since it's ASA, the side that's congruent is in between those angles. And if we can get these markings, once again we have congruent triangles. Our last one we have is angle angle side. So again we have two angles congruent to each other. And this time the side that's congruent between the two triangles is not between those sides. So it could be that this side is congruent to that side, or the other option is that this side could be congruent to that side. Either way, we have angle angle side congruent to angle angle side, which means then that we can conclude that those triangles are congruent to each other.